Hello and welcome to LIS4273. My name is Dr. Friedman and you are in Advanced Statistics and Analytics using R. Before I dive into what is Advanced Statistics and Analytics and what is open source R, I like to talk about the syllabus. And I will ask you to read the syllabus and to state that you understand the syllabus. The idea here is that the syllabus will be basically my guidance, and I will stand by this guidance, and I want you to fully understand what will be required of you to attend the class. So there's outcome and there's the idea of what we are aiming to do, but there's also a little bit more requirement that usually entails. We are going to cover two basically textbooks that I highly recommend you to purchase or maybe find an online version of it. And the reason for that is that if you're going to take my class in the spring about building your own R package, those two books will be required. And so those are the two textbooks that we're going to cover in this class. This is the main textbook that we will cover. It's a very technical textbook. It doesn't tell stories that you are accustomed to see in other textbooks that you experience. And so what I will do in my lectures is we'll divide the lecture into two parts. One is the technical aspect, how we conduct the type of analysis that we will cover in that model, and then we'll talk about the statistical implementation and how it's been done. So this is the technical, and I will give you background in my lectures about the module itself. This is also, the second book is also technical book. It's about the structure of the R and how we apply to it. Because there's so much to cover, I will try my best to do that, but the main focus of my class is about the statistics. And so this is what we will cover in the class. Back to the syllabus. What is expected of you? You're going to create a blog where you're going to, every module, you're going to answer the assignment on your blog. You're not going to submit the assignment on Canvas, but you're going to submit the URL of your blog entry to the Canvas. So I will be able to review it. I want this class to be transparent, so everyone will be able to see what you have been doing. Then, I am very keen on the idea of projects. This is where I think most of you will learn how to operate and understand what you have done. So the final project in the class, and I will discuss it later on, the final project in the class is 60%. You will find a data set that is of interest to you. It doesn't matter if you're coming from data science concentration, or you're coming from journalism or health science, and you want to learn about, you want to develop a project that involve a statistical module that we cover in class to this type of data analysis. You will demonstrate it and you will refer to it using the open source R. So this is the idea of the class, and this is what we're going to do. Otherwise, everything is going to be straightforward. I did a little revision of the textbook procedure. He started with probability theory. I left it to module number 3, where I will cover probability theory. Chapter number 4, where I will cover probability theory and review the code with that. So this is basically one-on-one on these textbooks, where in the end of each chapter, he provides example or exercise to do. Sometimes I will use those exercises for you to conduct, and sometimes I wouldn't. But I want you to have this book. It's not so expensive, and USF Library holds a copy of it. So I'll ask that you will have a copy of it. So this is the syllabus. Again, read it carefully, make sure that everything is clear, and ask question if it's not. Okay, so let's start with the idea of the course and why are we here. So, how many times did you hear that to do better than the average when your coach or your teacher said that in words? But we can also convert it into a formula, statistical formula, that will be able to measure if we do better than the average. So what is statistics? It is the idea that it's a group of methods, and again, I repeat, a group of methods that used to collect, analyze, present, and provide interpretation to data to help make better decisions. The idea here is that we are trying to measure performance of services or production process. We're trying to evaluate user compliances. We are trying to assist in formulate alternative course of action, and probably also justify curiosity from yourself or from others. That's the idea behind statistics, and the majority of the textbook in statistics talk about that. In the traditional statistics, usually there's two branches of statistics, descriptive and inferential. Descriptive, I think in the Introduction to Statistics course that you took in the university, usually it's about collecting, summarizing, and describing the data. Inferential statistics is usually drawing conclusion and making decision concerning the population based on a sample of data. And we will talk about that, the sample of data, because this is the main issue that we will cover in this class. So descriptive is about collecting the data, example surveys, and present the data in tables and graph, and try to come up with some understanding of the data using, for example, standard deviation. In inferential statistics, we're talking about the terminology that we are talking about is estimate the population mean that will help us to generate a hypothesis that we will test. Hypothesis is the idea that we are testing a statement about the population, and we will take a sample in order to us to verify if our assumptions are true or false. So we are drawing a conclusion and make the decision concerning the population based on a sample result. Nowadays, statistics added another dimension. We talked about descriptive statistics, we talked about inferential statistics, but the new area is called analytics, where time series, predictive analytics, and modeling are playing part in order for us to have better sense of how we can understand the data. But the key the definition and the key element in all those three paradigms is the idea of measuring. What are we measuring? And this is the key component in statistics, and the idea of the relationship between the data and the observation. And so we have the idea of population, which is the collection of all items or things under consideration. And we have a sample, which is a portion of the population selected for the analysis. And so this is the idea, population versus a sample. And again, this is the core foundation to our class. I gave you in this PowerPoint presentation, I gave you definitions and example every 10 years. the US government gather information of the entire population. Since the entire population is sample, it's referred to census. So again, what does it entail when we talk about population? The idea of sample is again selecting from elements from the total population in order for you to do that. If you remember correctly, before the final election last year for presidential candidate for president, U.S. president, they did a lot of samples in a state, sample in region, sample based on gender, based on income, based on education, and so on and so on. Why do we use sample? First of all, it's less time consuming, it is less costly administrative, so we do not have a lot of administration taking care of the entire population, and it's a very time selected that we can do and conduct in order for us to learn about the population. There's two types of sample: non-probability sample and probability sample. The item included in non-probability is without regard to the probability of occurrence. In probability sample, the items of the sample are chosen based on non-probability. That's why when we are trying to match and to understand what is the population is about, it is the preferred methodology is probability sample. So the idea of a sample is two types. And in probability sample, simple, random, certified, systematic, and cluster are the most common type of probability sample in compared to non-probability. And I will go over that in 2 seconds. But again, the framework of how we conduct or collect our data is key components. And so the items in the sample are chosen based on non-probabilities. So if we are looking at those 4 types of probability sample, this is what we can come up. So in sample random, every individual or item from the frame has an equal chance of being selected, and the sample obtained from a table of random number or compute a random number generate. And we will learn about that in practice using R. Systematic sample is decided on sample size n, and we divide the frame of capital N individual into groups of k, and we will say k is equal capital N divided by n. Then we will randomly select one individual from the first group and select the k individual afterwards. So in this case, the first group, and we have the data frame of 64, we have selected 8, and the k is 8. We will go over that, I promise. This is just the framework that I will elaborate later on. In certified sample, we divide the population into 2 groups or subgroups, and a simple random sample is selected from each subgroup with a sample size proportional and the idea of what it will convert. So example, in the election, or when they had the presidential election, they divided the groups not only to 4 subcategories, they probably divided it a little bit more in order for them to have a sample that will represent the entire population. Cluster sample is again the same idea, but different way of organize or sort the data. It is based on cluster, so each represent of the population, and a sample random sample of cluster is selected in order for us to have a good representation of the entire population. Again, a different methodology to select from the population. What is the advantage and disadvantage of this methodology? Sample random and systematic sample is simple to use, but may not be a good representation of the population underlying characteristic. Stratified sample ensure representation of individuals across the entire population, and cluster sample is most cost efficient, but it is less efficient, need a larger sample to acquire the sample level of precision, and we will talk about that later on. Data source. We have usually in academic or scientific research, we use the term primarily and secondary. Primary data is coming directly from observation or survey or experimental, and where we observe directly and collect the data. Secondary, which is commonly used by social scientists, researcher, is idea of we are taking data from, example, Facebook or Twitter or library collection or print, and we analyze the data and try to make sense out of it. We also have type of data. We have categorical data versus numerical data. Categorical data is an example of eye color or the political party the individual is identified with, or are you married or not. And numerical has two definitions, discrete versus continuous. Discrete is the number of children. Continuous is the weight and the voltage. Why is this continuous? Yes, today I gain weight because of the coronavirus and sitting at home all day, I gain weight, but hopefully after the corona will vanish, I will go back to nature and start running and start losing weight. So this is ongoing in compared to discrete, which is more settled down, more solid foundation. The level of measurements and the scale is also part of it. And the lowest level, we have nominal data, which is the lowest. And then ordinal data, interval data, and ratio data, which is the highest level. Nominal data is categorical, but there is no order or direction. Ordinal data is based on ranking, order, or scale. Interval data is difference between measurements, but not with true zero. That make the distinction between one another. And ratio data has a zero existence, which means that we have a scale that we can measure. That's why it is the highest level. So the most term in any textbook or statistical textbook is elements or numbers. Element or number of a sample or population is specific subject or object, for example, a person, a firm, or a country. Variable is the idea that it is a characteristics understudied that assume different value for different elements or number. Example, female versus male, income versus age, education, etc. Dataset is a collection of observation on one or more variables. In this class, we're going to focus on quantitative variables, which means that we are talking about numeric variable that is numerically scalable. And we're going to look at discrete variables versus continuous variable. An example of discrete variable, if you're supposed to flip a coin 2 times, this example has 4 possible outcomes. So in this case, the random variable x can have the value of 0 or 1 or 2, and that is discrete random variable. In continuous comparison is weight. Today I weigh 170 pounds, but hopefully next year, after everything will calm down and I will be able to go back to the gym, I will lose weight that I gain, and maybe I will weight differently. I hope this example illustrates that the textbook does not talk about that quite often, but I will give you in the Canvas more reference to it. Cross-section versus time series is again something that we will cover in our class, and there is a module dedicated to time series, and its cross-section is a data collected for different elements at the same point in time, in comparison to time series data that is collected in different points in time or different periods of time. And so the idea here is that we will have the notion of summary of terms, which is having the same format, and that's something that we will encounter in our final project. So I hope I'm a visual person. I like to see a lot of visual will be part of my presentation. So I hope you are ready for statistics. The second obsession I have, as I said before, is the open source R. The difference between R and Excel, and why don't we learn in Excel or SPSS, is that most those software, Excel and SPSS, are proprietary software. It owns to individual or company, and they always keep the code secret, so we cannot see what it is behind it. And the idea here is that is something that's been debatable in the computer science community. Why do we have this idea that software is closed gate? It does not show you what it is installed. So the open source opened that framework and open everything to everyone to see and be able to adjust to their needs and what they are looking for. Example, Mozilla Firefox is a browser that is open to everyone to use, or Apache or PHP programming language is open. Everyone can see what it is, and that's the beauty of it, and that's why so many people use that technology in order for you to do that. So what is R? Yes, it is the 18th letter of the alphabetical, but there's more than to it, and this is an article from the New York Times that describe about why data analysts captured by the R power. And so this is where R comes into play. A little bit history about R. It started in 1976 and it was discussed in Bell Labs. In 1980s and 1990s, it started as S language and created by one of the Bell Labs engineer called John Chambers. But it was not very popular and did not get much attention. And as you know, Bell Lab does not exist anymore. AT&T bought it, but they never wanted to develop the S language. So what happened was that in 1995, two professors from the University of Auckland took the S language and opened its source of the code to everyone to see. And they call it programming R. Why R and why not Z or T? Because their first names, Ross and Robert, was named after their first name. So the R environment is a little bit different from what we see in Python or any other place. In Python, we have libraries that we can incorporate. In R, we have the idea of a package. What is a package? If you look at R packages, inventories of R packages, today there is more than 35,000 packages. Those packages help users when they analyze the data to make the analysis easier or to visualize the data easier. And so it's becoming part of the R mechanism that you employ packages and allowed you to extend your research and analysis. So this is the idea of R. And one of the things that is really useful about that is a lot of packages that, yes, they have a lot of very inside look at what analysis can have, and it gives us the ability to provide a highest level or higher scale of analysis. So the R language is basically the language of interpreted. So it's object oriented and usually typically accesses command line, and basically it allowed us to have a particular ability to have to analyze a large set of data in compared to SPSS or Excel if you're trying to analyze a large data set. So an R package is, again, it's like, I like this definition a lot because it is language in 2009 says that an R package is like equivalent to a scientific article. They have a lot of standard to communicate the result, and the reader expect to be more, have some idea of what to expect in order for it to operate. And we will learn more about R packages in my next class, next semester, about how to create a package. So R allowed us to create special packages to share the data and the analysis and powerful visualization. And again, the number of packages always changes, and again, this is part of it. Always take. I used this 6,000 when I first came to USF, but it's always changing. Okay, there's two platforms to the R: the R console and the R Studio. The R Studio is not the R Studio become very powerful. Studio become the main platform, but this is the foundation, and the console is where they started in 1995. And so it is based on a DOS format, and it looks like this. This is what it was. And when I started to work in R, this is the platform that I used to work on in order for me to apply. The R Studio is a little bit more advanced, but again, there's a lot of interface that is easy to understand, and it allowed us to do. In the bottom, you will see the console where the interface of the first version of the R come into play, but you always have the upper window where you have the ability to run your code to work, and the other side, on the left side, you have the packages that you use, the file that you use, the workplace, and the history. So you have a script editor, a console, a variables, and view help and managing packages. So I like cartoons, and are you ready for that? And this is what we're going to focus. We are going to focus on probability, and because of the textbook, and I will give you also a framework to this textbook so you'll be able to apply. I hope you're ready for that, and I hope that you enjoyed the class. So next module, I'm going to talk about the R programming. I'm going to go over the foundation and how to install and how to run and how to pick up data set and everything else. And then module number 3, I'm going to talk about descriptive statistics. And module number 4, I'm going to talk about probability. You can find all those information on the syllabus. I hope you enjoy the class. It is really important class, and I hope you enjoy it. Until next time, have fun.